Okay, so now we need to talk about some significant digits. So what is a significant digit? A significant digit is any digit from 1 through 9. It is guaranteed to be significant. Okay? Trailing zeros are significant. So for example, the zeros in these numbers, they are significant. Okay? Any zero after a decimal space, any zero leading up to a decimal place. Okay? Sandwich zeros are also significant. So these are zeros that are within numbers from 1 through 9. So we have some examples there. Okay? Leading zeros, however, are not significant. So in this example here, this example only has 2 significant digits. Not 5, not 4, it's only got 2 significant digits. So counted objects and constants are not included in significant digits. Okay? So what does that mean? That means that if we have a value, we're not going to look towards that value in order to calculate how many significant digits we need. Okay? We're going to use the other given information in that particular situation. So, if we are multiplying or dividing, then we round our answer to the lowest number of significant digits. Okay? That's what we need to do no matter what. Whereas if we're adding or subtracting, then we need to round answers to the lowest number of decimal places. Okay? So this is very important to make this distinction. Now, if we need to calculate the mole. The mole, it is a very specific number. And a mole equals to 6.02 times 10 to the 23rd items. Okay? A molar mass is the sum of the individual atomic masses for each element in a compound. So we can find these atomic masses on our periodic table. So for example there, we've got 44.01 grams per mole, okay? 78.01 grams per mole, finally 230.45 grams per mole, okay? And the reason why we figure these out to 2 decimal places is because we're adding this together. We're adding the molar mass of 1 carbon and 2 oxygen atoms together in order to get our molar mass for carbon dioxide. Now, if we need to make calculations for molar mass or mole and mass calculations, okay? So the number of atoms is going to be the mass divided by the molar mass, the number of moles, okay? Where if we need to find the mass, we're going to take the number of moles and we're going to multiply that by the molar mass, okay? Again, here, N is the number of moles in MOL. So that is the, that's the units that this is in, okay? M is the mass in grams, and the molar mass is in grams per mole, okay? So if we have an example here, so example 1, how many moles are in 0.86 grams of magnesium oxide? Well, first of all, we have our mass, okay? We need to figure out our molar mass, and in this case, we figure that out by using our periodic table, okay? What we need to find out is the number of moles. So I'm going to use the following formula, okay? I'm going to substitute in my answer, or my values, and I'm going to work out my calculation, okay? So in this case, I got to round up, and I'm going to round up here again into 3 significant digits. And the reason why I'm doing this is because my mass has only 3 significant digits. If I'm looking at my example 2, so what is the mass of 0.677 moles of potassium sulfide? Well, this is what I know. This is what I don't know. Okay, I'm going to use the following formula. I'm going to do my substitution, and I get my answer. Sorry, 74.65 grams, okay? So I got to round that up to 3 significant digits because the amount of moles that I have only has 3 significant digits in it, okay? So your assignment is to do page 10, the first half of page 11, where your review assignment is going to be to finish page 11 all the way to page 13. Thanks for watching.